Okay, welcome to week 4. In week 4, we're going to take a look at SQL, which is an acronym for Structured Query Language. Many people pronounce this as Sql, but my understanding is that Sql spelled out is another query language, so I'm going to try to remember to call this thing SQL, but I'll probably forget. All right, so SQL is a more or less standardized language for interacting with relational database management systems, or RDBMSs. So a database management system is a system that stores and allows you to administer and fetch and update information. A relational database management system is a database management system that does this using what are called relations, which we just think of as tables, basically, with columns and rows. In technical RDBMS language, these are referred to as attributes rather than columns, and tuples rather than rows. But you can just think of as a relation. You can just think of a relation with attributes and tuples as basically being a table with columns and rows. All right. So there are other kinds of database management systems, but the most common ones are the relational ones. And you need to know something about SQL in order to be able to interact with the data stored in these relational database systems. In this brief week-long presentation, we're mostly going to ignore database administration issues, database security issues, and so on, and just focus on how you go about accessing data, how you go about adding data, how you go about adding tables to your database, and so on. The software we're going to use to illustrate this is called Postgres Sql, or Postgres Sql. This is a freeware open source system that runs on most operating systems. It runs on Windows, Mac, and Linux, and it's very easy to obtain and install. So we're going to go out to postgresql.org. Let me pull my browser up. Okay, so postgresql.org/download, and here we are, and you can see that it provides packages for many different systems. I happen to be on Windows, so I'm going to select Windows. If you're on a Mac, you should select that, obviously. And we want to download the installer for the database for our system. I'm going to ask for version 13, which is the most up-to-date, stable version of this thing that is available for Windows. So I will pick Windows with version 13.4 of the RDBMS, and you can see I'm using Chrome as my browser, so you can see this prompt in the lower left corner showing me the download progress of this thing. All right, and it appears to be downloaded, so I will show this in my folder and launch it by double-clicking. Any day now. Okay. Now, I don't know if you can see this part. I have a user account control window on my screen asking me, do I want to allow this application to make changes to my device? I'm going to say yes. You may not be able to see this interaction, but when I say yes, it will pull up a download application any minute now. And I'm going to clip out excess time from this whole process. Here we go. Here we almost go. There we go. Okay, so welcome to the setup wizard. I'm going to click next. I am quite content with the default location that it wants to use, so I'll click next again. I am happy to install all of the components, so I'll click next. And I'm happy with where it's decided to put the data tables, so I'll click next again, or the databases, I should say. Password. Okay, so here you pick whatever password you want for your database, and mine, well, I won't tell you mine. You can pick your own. Alrighty. Select the port number. All right, I'll just choose the default port number 5432 for communication with the server. Select the locale. Default locale is just going to default to basically the ASCII character set, so that's good for me. I'll click next. Following will be used for installation. And this basically just reflects all of the choices that I made, and I was happy to pick all of the defaults. So I'll just click next, and now it's ready to begin. I guess I have to click next one more time to have it do its install. There we go. Now we wait. Okay, so everything is done. Stack Builder may be used to download and install additional tools, drivers. I don't really care. I'm going to uncheck that. And I now have this Postgres Sql database management system installed on my machine. In my Start menu on Windows, I'm going to find that this has been installed. I'll scroll down to the P's here. And here we are. Here is my Postgres Sql 13. When I see the applications contained in that folder, one of them, notice, it's a little hard to see. I'll drag down a little bit more. There we go. Is the Sql Shell, PSQL. And that you can right-click and pin to your Start menu, or you can also put that in your Open File location. Well, you may not be able to put that in your taskbar. In any case, I do have it in my Start menu. Let me move the icon up where we can see it. I'm going to move MATLAB down and Sql Shell up, and I can run it now. And there we go. And this gives me a terminal-style interface in which I can communicate with my relational database management system. Okay, and I've now resized that PSQL shell window so that it only occupies the right half of my screen here. Okay, so this is easy to get installed and running. Just take defaults for everything. And then locate how to execute your SQL shell, and you can now interact with databases, create databases, add and remove tables in databases, and so forth. All right, so the RDBMS is the entire relational database management system. And within that system, you can actually have many different databases. Okay, so you could have a database for your finances, a database for your marketing, a database for each various different research group, each trading desk, whatever. A database, in turn, consists of a number of so-called relations, which we ordinarily just think of as tables. And each of those relations has some index that we can use to identify the unique values within the tables. Okay, the values or records within the tables are referred to as tuples, and each field or column within the tuple is referred to as an attribute. We can just think of these things as being tables with rows and columns. And there is some index that identifies a unique row, a unique tuple within this table. In the relational database system philosophy concept, each table has to have one so-called primary key that distinguishes each tuple from the others. Okay, it's a unique identifier for each individual tuple within the table. It's also possible to have additional keys called foreign keys that allow you to link together the values in one table with values in some other table. And basically, the reason for these indexes is to optimize the speed of access of records in the various tables. Okay, so for among other things, we can, in addition to being able to create tables, add and remove tuples from tables, sort the tuples according to various attributes, etc., we can also join together different tables, assuming that those different tables have keys in common with each other. Now, in terms of the program that supports all of this stuff, the relational database management system has a server process. That server process may spawn subsidiary servers that handle interactions with individual databases within the overall relational database management system. And the server processes basically act like traffic cops to prevent different requests from stepping each other and to organize the requests into a sequential order. It also handles security and backup systems, etc. Then a so-called client process is another program that talks to the server to make requests, either requests to create a new table, add columns to the table, add data to the table, and also query information from various tables and various databases. Sometimes, in fact often, nowadays, these clients are graphical based or web based, but in our case the simple client that we have is this Sql Shell, which gives this SQL shell, which gives us a command line oriented interface for talking to the underlying database system. Okay. Whoop. Okay, so here is an image of our SQL shell, and let me switch back to the real And let me switch back to the real shell here. Okay, so there's our real shell. We're indicating which server we want to communicate with, and we only have one, and it's running on our local machine. So localhost in brackets there indicates the default, so I'll just hit the enter key here. So I'm now talking to the local host, and one of the databases on this local server is the default Postgres database, and I'll go ahead and just use that one for my illustrations. My port, I accepted the default 5432, so that's good. And as username, I'll just go ahead and use the default as well. Now I'm asked for my password, and I hope you remember what password you gave before, so I need to type in my password here. All right, I've done so, and I hit the enter key, and okay. I get a warning that I can ignore, and now I will ask for help. I'm told you are using PSQL, command line interface to the Postgres Sql system. I can use \h to get help with individual SQL commands, or \mark to get help with the shell's commands. Okay, so SQL is the standardized language for interacting with databases and tables within databases and data within those tables. PSQL is the shell application that has its own collection of non-standard, well, they're standard for PSQL, but they're not standard commands for interacting with other kinds of client processes. Okay, I can use \G to execute a query and \Q to quit. So let's get into this. All right. One command I can use, well, I'll use \h to see what SQL commands are available to me. Okay, and I get this very long list. We'll look at several of these, but not nearly all of them. A lot of these have to do with creating, deleting, and modifying databases within the overall database system, and also, or tables within the database that we're using in our relational database system, and also adding and removing data from these tables. Only a few of them, like select here, will allow us to find out about the data that's contained in these tables. So we've got one command here, select, that we're going to use a ton, and then a whole bunch of other SQL commands that we're going to use now and then. In terms of the shell's own commands, \mark shows me what commands are available for me to use within the shell itself. And one of these is I can use, where's it hiding? Maybe it went off the top of my screen here. Oh, fascinating. I'm not seeing it here, but I can use, oh, there's more to come, so I need to press the space bar. Input, output, conditional, informational. Sorry about that. I forgot about that. And one of these that I guess I scrolled by was \L, which will list the databases that we have available within this server relational database system. So we have a database called Postgres that we're not going to mess with, and we have a couple of other databases called Template 0 and Template 1 that we're likewise not going to mess with. Let us take a look at categories of these commands in the SQL language. Okay. There are basically 5 categories of commands here in this SQL language. There's first what are called the data definition language commands, and these are the ones that allow me to create new databases, eliminate new databases, create tables within databases, change names of tables within databases, etc. Then there's the data manipulation language, which allows me to add data to a table or remove data from a table. The command for doing queries is, as I said, this command called select. And select is enormously powerful and enormously complicated in terms of the number and meanings of options that select takes. Actually, select is the one that we're going to be most concerned with. And if you get asked about SQL in interview situations, it's likely that you are mostly going to be asked about select commands. How do you, given this database with this table with these attributes and tuples, how do you go about finding out such and such information? And that involves using a select. There are transaction control statements that allow you to, all right, you can do a series of changes to some tables, and then you can commit all of those changes all at once. Or if you discover that you've made a mistake, you can roll back to your most recent commits, and you can also, in terms of permissions with this data control language, you can grant and revoke various permissions. Okay, so let me first use one of the data definition language commands, namely create. I am going to create MyDB. Now, interestingly, when I say create MyDB and hit the enter key, nothing has happened yet. I have typed in a command, but nothing has happened yet. I have to say \G to go with that command. At or near. Oh, silly me. I forgot to say database. Okay, so we need to say create database MyDB, and then we can go with executing that statement, or I can give a series of statements actually, and then hit go. Now, the create database is done, and so if I list my databases now, I'll see that I do have MyDB in addition to the 3 default databases that got set up for me. The opposite of create is drop. So if I want to get rid of a database that I no longer need, I can say drop MyDB. And as an alternative to using \G, it turns out that in SQL I can just type a semicolon to conclude my command and to tell the SQL shell to go ahead and execute that command. I'm sorry, I keep forgetting to say database MyDB. Because I'm going to end up using the same create and drop for dealing with tables within a database, in addition to dealing with databases themselves. Okay, so I've now dropped the database, and if I list with \L, I see that MyDB is now gone. All right. As an abbreviation, or let me recreate this database, MyDB again, database, MyDB. All right, so the database now exists and is empty. \c, MyDB, is the way that I tell my PSQL shell that of the various databases available to me, I want to specifically interact, well, I haven't listed them, but if I list them, I will see that I do now have MyDB, and I want to specifically connect to that MyDB database. Okay, so \c is going to connect me to MyDB, and I'm logged into this system as the user whose name is Postgres. So, create database is how I create the database as a whole. If I want to create a table within the database that I'm connected to, I say create table, and then the name of the table. In this example here on slide 11, I'm creating an investment attributes table. And this will feel similar to a data frame example that we did when we were talking about pandas. So I want to have a table of investment attributes, and one of my investment attributes here is going to be the ticker for a stock. I could have just typed this stuff in from the left edge, but usually it's formatted to make things look nice. Since I've typed this opening parenthesis here, notice that the prompt, the shell's prompt changes to indicate to me that I am within a multi-line command here. varchar is the long-winded, whoops, varchar 8, I didn't mean star there. Varchar is the long-winded way of indicating that you want some attribute to contain a string. So in this inv adders table, my first attribute is going to be the ticker, which I'm going to set to 8 characters. Now that's way more than necessary, but that's fine. You may remember that I said that each table has to have some primary key, and because my tickers are going to be unique, that is, I cannot have 2 instances of the same ticker in my description of investment attributes, I'm going to label this attribute as the primary. I knew I could spell that eventually, as the primary key. Okay. Double dash is a comment, so I can say ticker is unique. And because ticker is unique, I'm going to use that as the primary key for this table. Now, you may remember that we were interested in knowing whether the CEO has recently been buying the stock. That's a Boolean attribute. And another thing that we care about is the return percentage. And that's a real number. All right, so instead of int, stir, float, bool like we have in Python, here we have varchar with a certain size for representing strings, and you just need to make sure that the size you specify is longer than what you might possibly need. Boolean instead of bool, real instead of float. Actually, real. In addition, we could have int for float. Okay, I apparently can't highlight and talk at the same time. Okay, so real is for float. Then we also have int rather than integer, and we also have date and time data types that we can use for attributes within our table. All right, well, that's it as far as the attributes that I want for this table. So now I type my closing parenthesis, and rather than using \G, I'll just hit the semicolon here to indicate that I'm done with this SQL command. And I have now created a table. Cool. So list shows my DB, whereas describe \D shows me the tables that I have within the database that I am connected to. Okay, so I want to be clear, these are not SQL commands. These are PSQL, SQL Shell commands unique to Postgres Sql. All right, so \L for listing the databases that you have, and \TD, pardon me, for describing the tables that you have, the relations that you have within the database to which you're currently connected. Now, at this point, my database has no data in it. So I'm going next to use the insert SQL command to put data into this table. And this is an actual SQL command. I'll say insert into INV adders the values, Apple as my ticker, true for CEO by, and 20.75 for the price, which is absurd, but what the heck. And I neglected to say semicolon or \G. There we are. So now I have done an insert. This method of insert, where I say insert into some table some values, will put the values in the order in which those attributes were created. If I want to put the attributes in and specifically give the names of the attributes that I'm using, then I can be a little more verbose and let me, rather than manually typing this in, I'm going to, actually no, this is a screenshot, so I can't copy and paste. I'll have to manually type this in after all. So I'm going to say this time insert into INV adders, and I want to specify that I'm going to first give the ticker, then I'm going to give the CEO by value, and then the return percentage value. And the values that I'm going to put in are, and I ran out of space, so I just, after my parenthesis, I hit the enter key. Cisco, false, and 18.12, which is ridiculous. And this time I will remember my semicolon. All right, so in the first insert command here, I gave the values in the same order in which I had created the attributes. In the second insert command, I'm specifying the order of the attributes that I want, and then I'm specifying the values in that same order. Of course, that's the same as the default order. Whoopsie, what did I forgot my comma. Silly me. So let's try this again. Insert. No, I can't copy and paste here. All right, so I'm going to copy this. And this time I'll remember my comma. There. And so now I've inserted another value. And the advantage of being able to specify the attributes is that I can change the order if I want to. So I can first give the value of my CEO by attribute, and then the return percent attribute, and then the ticker attribute last if I wish. All right, so this time I have CEO by first, so I'll say false. In this case, return percent 8.72, and ticker is US Steel X. All right. So I have now, using these three insert into SQL commands, put three tuples into my relation. That is, I've added 3 rows to my table. And if I want to see all of the rows, I can say select star from the table in vaddrs. Okay, so select is how you extract things out of tables, and also, using or not using keys, and doing quite elaborate logical combinations of things. Here, I'm just saying select everything from the vaddrs table, and they are displayed. Okay. Now, this mechanism for inserting individual values into tables is kind of painful. You can insert a whole bunch of values into a table using a single insert into command and giving a list of tuples as values. So that's what I'm going to do here. I'm specifying the ticker as well as the CEO by flag and the return percentage. When I say values, this time I'm going to give a sequence of tuples rather than just a single tuple. So we'll have Goldman Sachs, false, 17.17. These prices are pretty ridiculous. Then we're going to have BA, true, 14.12. And J&J, Johnson & Johnson, false, 11.92. And now, right at this point, I could use my semicolon. On slide 13, I'm showing the semicolon at the end. Either way, it doesn't matter. And once again, I forgot my comma. So let me grab that. Grab this. Okay, I'll type this in and clip this part out of the video. Okay, so that time I did not make silly typos. And you see that I've added 3 more tuples into this relation. And then when I say select star from vaddrs, I see that now I have 6 records in there. All right, well, I think I have demonstrated how you can insert new records or new tuples into these tables or relations, and I've also demonstrated how clumsy this is to do interactively. We can put stuff into a file. And notice that the extension for this file is .sql. So this time around, I'm going to create a text file called dow.dat.sql, containing information about several Dow stocks. And I'll show how from within PSQL we can cause this file to be executed and cause several more tuples to be added into our relation. All right, so let me pull up that file. All right, so here is that file. I created it just using Notepad. And I have saved this thing named dow_dat.sql. I happen to save it in my own downloads directory so that it will be easy to find. The PSQL command, the Sql Shell command that I use to cause the shell to read commands from a file is this \i command. And so let me scoot my file over here and I'll say \i. Now, on slide 15, we just gave the name of the file, and that works if you happen to be executing your shell in the same directory where the file is contained. But as I said, mine is in the downloads, in my downloads directory. So I'm going to have to type, and notice that I use forward slashes here. Users jostland downloads dow dat.sql. Okay, so now my shell is going to pull in this sequence of commands from this file. This sequence happens to be just one single command, ended with the semicolon down here, and it's going to insert a bunch more data into my table. There, 10 more values. So if I say select star from INV-attrs, we see that I now have a lot more data in my table. You can have data stored in a comma-separated value file. So this makes it easy, for example, to obtain data from the web, or obtain data from Excel, or obtain data in some other comma-separated value format, and pull in the data from that CSV file. Here I have dowdat2 that shows in ticker, CEO by, return % order 4 more Dow stocks. And this time I'm going to use the copy psql command to copy from the CSV file into the INV-attrs relation. Table relation. I forgot the word. And because it's a CSV file, now psql isn't bright enough to understand that .csv means that comma is the field separator. So I do have to actually specify delimiter and then a string containing my comma delimiter character. Okay, so here is my dowdat2 file in my downloads directory, and I will now execute this copy command. So \copy INV-attrs from, and I have to specify users jostland downloads dow.dat.csv. That's my file, and I'll just keep typing. Delimiter is a comma. Poof! No such file. Users jostland downloads. Silly me. Dowdat2. Okay, so now I've fixed that typo, and it worked. Copy 4, and now I can select from select star from INV-attrs, and we see that we now have 20 rows, as we are supposed to. Good. All right, so now we're going to look at some real data of a much larger size, although still not enormously large. Here on slide 18, I have the top few lines from a file named dow30_2018.csv. And this file contains price information for every trading day during 2018 for the Dow 30 stocks as of the end of 2018. Okay? So we have the date, we have the ticker symbol, and then we have the opening price, high price, low price, low price, close price, volume, and adjusted close. And these are actual values. I have, in addition to this data file, I also have a code file. Here is dow30_2018.sql that will create a table to contain this information. So this is a create table SQL command, and I've given names for all of the columns and data types for all of the columns. Now, as slide 19 mentions, which I skipped over, in this particular case, neither the date nor the ticker is a unique field, right? We've got a whole bunch of stocks for each trading day, and for each stock, we have a whole bunch of trading days. And yet we said that each table in an SQL database has to have a primary key. Well, it turns out that if you think about it, the combination of the trading day and the ticker is unique. If we have two lines that have the same trading day and the same ticker, then that's some kind of error. So what we're doing is we're using the combination of date and ticker as our primary key. And notice that we have added the fact that our primary key consists of the date and the ticker at the bottom of our create table Sql command. All right, so I'm going to first execute the Sql command to create this table. And the name of the table is Dow30 Okay, so here's the table that we're going to be creating. And then I'm going to copy from the CSV file into this newly created table. As before, I have put these things in my users JOSLN downloads directory. So let me go ahead and execute these commands. I'm going to first execute users JOSLN downloads Dow30 2018.sql. All right, so that has created a table. I'm going to use \d to see the tables that exist in the database that I'm connected to. I used to have just this INV adders table that has 20 rows in it. And now I've created this Dow30 2018 table that at this point is empty. So if I say select star from Dow30 2018, I get 0 rows back. The copy command here is going to load that comma-separated value data into this table. So that's my next thing to do. Copy into the Dow30 2018 table from my comma-separated value file. Users JOSLN downloads Dow30 underscore 2018.csv, and I'm specifying that the delimiter is a comma character. You may notice, let me skip back to slide 18. In this comma-separated value file, we do actually have a header line at the top. All right, and that's not part of the data. I have given those very same label names, with the exception of clipping out a space character. I've given those same column names as the attribute names in my table / relation that I'm creating in this database. And I want to, in my copy, tell the copy that this is a CSV file with a header. And so the header should be skipped and not included along with the data. So CSV header should be skipped, and poof. All right. So that copied in 7,530 lines of data. Cool. Well, now that I have real data to work with, we can start taking a look at some more interesting select statements that will allow me to select various portions of this data and also do analysis on the data. If you ask for help on the select command, we get this huge amount of output. So the select command in SQL has many options that modify and determine how the select command behaves. All versions of relational database systems that support SQL do support a select command, with many, or perhaps most, probably most, of these options that are shown here. However, this is not fully standardized, and so you do need to be careful that any given relational database management system that supports SQL will not necessarily support all of the same options and all of the same additional arguments that all the other versions of SQL support. It's kind of a standard, but not absolutely standardized in the way that many programming languages are fully standardized. All right, so here's an example. Let me finish showing the details of select. Okay, so there's just a ton of stuff here. If I say select star from the table, Dow 30, 2018, I get every record in the table. And this is just going to go on and on and on. If I hold down the space bar to... When I see more here, I can tap the space bar to continue the next page. Actually, I'm sick of looking at this. So I can also press Control-C to get myself back to the prompt. And there are however many lines there were. We were told that there were 7,530 lines of data. Now, one of the most common clauses to use in the select command is where, which allows you to specify that you want just a certain subset of records where one of the columns is some specific value or some range of values or matches some kind of pattern or whatever. So if I select star from Dow 30, 2018, where the date field, the date attribute, is equal to 2018-01-02, this is going to give me just the records for the first trading day of the year. And it's not going to be a big surprise that there are 30. Yay! Okay, so that's the Dow 30 stocks, at least for the year 2018. And that is the 30 rows for that particular trading day. If I ask for all of the columns from Dow 30 2018 where ticker is Apple, then, okay, this is going to go on for a while. 251. Okay, not shocking at all. So there are 251 trading days in the year 2018. All right. In addition to selecting everything, which is what I get with star, I can say that I only want certain columns. All right, so in this instance, I'm going to say select, and rather than star, I'm going to say just the date and the ticker from this table, Dow 30 2018. And oh, I was confused for a moment. Okay, so this is going to give me every day and ticker pair, and of course there's we already know that there's 30 stocks, and there's 251 trading days, so this is going to give me 251 times 30. This is going to give me 7,530. All right, 7,530 records. I for some bizarre reason, I was expecting to only get 30. And remember also that this pair of values, the date and the ticker combined, that is our primary key for this data set. Next, I can ask for, I'm going to hit Control-C, I can ask for, let me ask for the high price during the day and the low price during the day from the table, Dow 30 2018. But this time where ticker is just a particular stock. Okay. So I'm just asking for one of the stocks, and I'll get 251 rows here. But I'm just getting the high and low price for this particular stock. Now, I can ask for star, which means to show me every column. I can ask for high comma low, which shows me the high price and the low price. I can actually do an arithmetic computation, or for that matter, a logical computation, logical combination, using arithmetic with values from certain columns. So here I'm asking for, I'm going to hit Control-C to get back to my prompt. I'm asking for the midpoint between the high price and the low price from Dow 30 2018. For, whoops, forgot my where, for, or where ticker is BA. Okay, and so here I have the midpoint between the high price and the low price for each trading day. Because I did a mathematical, an arithmetic computation here, the select statement is unable to display a column name in this case, but I can patch that up as well by specifying as mid. Okay, so I can say select some mathematical expression as mid, or whatever name I would like to have for this resulting column, from the table where, in this case, the ticker is BA. So let's do that one as well. Now, by the way, in the PSQL shell, I can just use the up arrow to get back the previous command that I had typed in. So I can just say as mid here and re-execute this modified command. All right, so there I have the same values, but I've got mid as my column name. If I'm interested in knowing how many records in the table satisfy my selection with my where clause and so on, let me hit Control C. I can execute the count function. So if I say select the count of all of the fields from Dow 30 2018, well, count is sort of like len for collections in Python, and what I'm going to get told is that there are 7,530 total rows in the data set. If I do a select of count star from the table, I should just use up arrow, from the table where the ticker is INTC, well, okay, we know that there should be 251 trading days in in this year. So unless for some bizarre reason there wasn't a registered trade for Intel on a certain trading day, I should get back 251. And on the other hand, if I select count from Dow 30 where the date is a certain specific trading day, 01/02/2018, I should have a record for each Dow stock, so this should be 30. Okay, so that's some very basic, straightforward select statements. We say select, then we have some kind of expression. It may be star to indicate that we want every column in the in every row. It may be count of star to indicate that we just want a count of the matching records. It may be one or two or three specific columns separated by commas from each other. Or it may be some arithmetic combination of certain columns. Then I say, from the table that I want to get records that I want to access. And finally, a where clause here, which is optional, if I only want to restrict the matching to columns that to some column having some certain value or some set of values. Now, we're just using individual values here. Now, the star in this count case doesn't really matter. I could say select a count of the dates from Dow 30 2018. This does not mean to count the number of unique dates. It just means to count the number of times that the date column has a value in it from this table. And it's the same number as when I said count star. Okay, so for count, you might as well just say star. It doesn't matter what particular field you give. Also, if you say select ticker date close from Dow 30 2018 where, let's say date is equal to 01/02/2018, I'm specifying the columns that I want, and I get the output in the same order that I specified those columns. I guess I shouldn't have hit the enter key so fast. So here is my select statement. I want to get the ticker and then the date and then the close. All right, so the order of the fields in my select statement also specifies the order in which those columns are displayed to the output. All right, well, that gets us to the end of part 1. And in part 2, we're going to look at a bunch more SQL statements.